All right, so this is the new topic is solving systems of linear equations in three variables. So the difference here is in the past, in the previous videos, we've only had two variables. We've had x and y, and we've solved those systems. Okay, and this last thing that we're going to go over is we're going to add a third variable. So we're going to have x still, we're going to have y still, but now we're going to have a z variable. Okay, and what that means is the x and y, if we think of it as a plane, as the xy coordinate plane, right? It's a two-dimensional figure, just a flat plane. When you add a third variable, when you add that z to it, what it does is it creates three dimensions. So this would be a three-dimensional thing. So now we're in three-dimensional space. So we're not going to go too far into it, but that's kind of the reason why we add the third variable, because we want that third dimension. You go on to calculus and go on to very multivariable calculus, you eventually graph these in three dimensions. Sorry, my screensaver is on. Anyways, what we're going to start off with is something kind of very simple, and you probably could figure out how to do this without me telling you, but just fast forward if you get it. But this is kind of the first thing that they have you do, and this is on the test, but it's worth learning if you don't know. Is they give you, it says, let's read the question, I guess, and then I'll kind of explain what they're having to do. It says, decide whether the given ordered triple is a solution of the system. So, usually we have an ordered pair because we only have an x and a y, but in this case it's an ordered triple because we have, we have our x, we have our y, and now we have our z. Okay, and so basically it says decide whether the given ordered triple is a solution of the system. And if this was two variables like we have done in the past, a way to check to see if it is a solution is to plug the x and y into the equations and see if the left side equals the right side. And if everything is true, then it is a solution. But let's say it was true for one equation and not the other, then it was not a solution. Or if it's not true for either equation, it's not a solution. And the same thing here. Now instead of just checking, two equations, we got to check all three equations. And if all three equations work, if the left side always equals the right side, and all three of the equations, it's a solution. But if it fails in any of the three, then it is not a solution. Okay, and so basically the idea here is you just start plugging in values. So let's start with this first one here. So we're going to plug in 0 for x, 3 for y, and 1 for z. So I'm going to have 0. I'll do this first one the long one, and then the other ones will do kind of quick. So 0 for x plus 2 times 3. 3 is the y, and z is 1. So we're going to have plus 1 equals 7. And if you can see here, we're going to have 0 plus 2 times 3. Well, 2 times 3 is 6. So we have 6 plus 1 is 7. So 7 equals 7. So that one works. So this is good. That means it could possibly be a solution. But just because one works doesn't mean the other three will work. So let's try the other three. Let's get a different color here. So this one we're going to go kind of quicker. So 0. So 0 plug in for x. We'll have 4 times 0 is 0. Okay. Negative or 3 in for y. So we'll have minus 3. And then we'll take a 1 here. And so we'll have plus 1 for z. 1 times 3 is 3. So we're going to have plus 3. So negative 3 plus 3, does that equal 0? Yes, it does. So this one also works. Let's try the last one here. We plug it in. So we plug in 0 for x. We get 0 times negative 2, and we get 0. So we're over here now. We got 0 for that first one. Plug in 3 for y, and we get 3. And negative 5 times 1 is going to be a negative 5. And does 3 minus negative 5 equal negative 2? Yes, it does. And since every single one of these works, then yes, this is a solution. Okay? If none of them work, it's not a solution. If 2 of them work and 1 doesn't, it's not a solution. If 1 of them works and 2 are not a solution, it's got to be all 3 for it to be a solution. So if any of them fail, 1, 2, or all 3 of them fail, it's not a solution. Okay? All 3 have to work. Okay? And when I mean work, I mean the left side has to equal the right side for it to be a solution. Okay?